called part 12. In this, we are going to see about the CAN bus termination. This is one of the important and interesting topic in CAN protocol because this makes the CAN protocol unique. So CAN bus termination. So let's see how the CAN bus termination will be. So in most of the cases, so if you think about like 120 ohm resistance, so there were in some cases there will be the direct 120 ohm resistance will be given like this, and somewhere it will be like packed one. So it depends, but even though if you open this packed one, you can see the 120 ohm resistance like this. So it will be it will be the resistance between the CAN high and low terminals. So in this case, this may have the problem with the soldering, those kind of stuff, so that we can have the packed one, so it will be very robust to handle, so there won't be any problem until the resistance goes off. Let's see why this 120 ohm resistance comes and how and what is the origin of this. So this CAN bus termination is from the ISO 11898. So this ISO organization, that is this standard, has made the CAN bus must be terminated because this is done using the 120 ohm resistance at the each bus, because there's a two purpose. If there is no termination, then there will be the signal reflection at the end of the bus, and there will be no correct DC levels as it is the digital signals, so there will be the no DC levels. So that's why this is the main two purpose which makes the CAN bus to be, the proper in the data transmission also happen the right way. So this is what the purpose. It will remove the signal reflection at the end of the bus, then it ensures the bus gets correct DC level, that is the correct message. This includes the problem with the corrupted signals may corrupt. If there is any problem in these, then the signals may be corrupted, or it may be the error signals, so and so on. So this is the two main purpose. The physical layers such as low speed CAN, single wire, and other may or not require the termination, but high speed. So this is also one myth, that low speed CAN doesn't need of 120 ohm resistance. But nowadays, so we are using 120 ohm resistance for all, because to avoid even the 1% of error. So as the in our previous tutorial, we have mentioned that the propagation of wavefront in the CAN, because of the arbitration, so that wavefront may propagation may causes the signal reflection. So in our case, in our industrial standard as well as automotive standard, we are not bothering about the termination of 120 ohm, because as you know, it is a very the cost is very less than 120 ohm resistance will cost around 20 to 30 Indian rupees. So it is so cheap that so you can use, even though if there is any problem, you can easily change it by just a soldering. So even the low speed as well as high speed you can use, but in the ISO 11898, it is recommended only for the high speed, because yes, it will as it is a high speed, there will be more signal reflection. So once the 120 ohm resistance rises, the signal reflection will be controlled. So this ISO 1198 prescribes that cable impedance be nominally 120 ohm, but an impedance is an interval of 108 to 132 ohm is permitted. Yes, of course, the theoretical proof is prescribed for the 120 ohm, but in the practical scenario, we may use like 108 to 132, as there is all the distortion loss, then it will be capable of 120 ohm. But as from 108 to 132 also it is applicable. So if you want to do some R&D, then you can go ahead with, instead of 120 ohm resistance, you can go ahead with 108 or 101, some 110 to 130. You can try whether it is working fine or not. Yes, obviously it will work. There are not many cables in the market today that fulfill this requirement. There is a good chance that the allowed impedance interval will be broadened in the future. Yes, so the impedance, whenever the impedance goes more, then the signal reflection, the efficiency will be still higher. But of course, this cable is sufficient to allow this impedance for a better output. So that is a sake that we have been used 120 ohm resistance. But yes, they are try to keep on include the, as I said, you can do some R&D on 120 ohm resistance to 130 resistance. So if you also go like 150 160 ohm resistance, but what will happen is you will not get a proper signal. For that, again, you have to change some other parameters, so that parameter will impact another parameter. So in this way, you have to do some R&D if you really interested in. Yes, of course, some R&D fellows are doing that, but this is the outcome of that. So maybe in future it may be broadened. This ISO 118 is defined for only. They are also designed for the twisted pair cable. Yes, that is what the definition they have given. It is for the twisted. So they just they implemented the twisted pair, shielded or unshielded. That is what the can satisfies. Hence they are going with it. So the for the can cable they are just making this 120 ohm resistance. So these are all different it's a parallel route. So it is not a, while they manufacture the can they have not implemented this 120 ohm resistance, but of course the can is a protocol that has been implemented. But this ISO 11898 has brought in the the impedance of 120 ohm resistance, which will really makes the signal better. So the R&D is in progress on the single wired standard SAE J2411. So this may be in future, maybe in the next decade, they may start to use of the single wire standard as we are using the two wire CAN cable now. So this is a very simple thought, simple stuff that I thought to share with you. That yes, of course, it should be there. Why the 120 ohm can resistance is there? So the many answer is it is want to just ignore the signal reflection. It may give the correct DC levels by not correlating or not corrupting the signals. But the reason is ISO 11898. Yes, if you really wanted to know more, yes, you can go through this ISO 11898 so that you can come to know more and more about this 120 ohm resistance. So we'll see in the next part of the CAN bus connector, that is a physical bus connector. Yes, of course, you may know what is the CAN bus connector is. Yes, it's a DB9 connector. And in an upcoming tutorial, so what the DB9 connector really do, and what are the male and what are the female connectors, that which pin is used for what. So those things can be discussed in the upcoming tutorial. So until then, you just watch once or twice to just make the better understanding in this 120 ohm resistance. Also, I recommend please do refer this ISO 11898. Catch you in next tutorial.